Moving on with homework 2, let's go to problem 4. The statement for problem 4 reads, calculate the linear atomic density in atoms per millimeter for the following directions in FCC aluminum, which has a lattice constant of 0.405 nanometers. In this video, we're only going to solve part C, direction 111. If the same steps are followed in this video, parts A and B should be easy to solve. To begin, let's start off with the formula for linear atomic density, which is rho is equal to the number of diameters we cross in our given direction, which is 111, over the length of the line that's created in direction 111. Now that we have the formula down, let's go ahead and draw our direction 111. And it might be a little hard to see it in the diagram that has the atoms, so I drew a little box at the bottom. We always begin by drawing or by starting at the origin, which is at the bottom back of the cube. 111 is going to take us to the top front of the cube, and we go ahead and connect that. Now, let's determine the number of diameters we cross. We pay close attention to it. We cross half a diameter due to the corner atom, and another half diameter due to the other corner atom. So half diameter plus half diameter gives us one total diameter. Therefore, we cross one total diameter along this direction. The next part, which is the hardest part for these problems, is determining the length of this line. In order to do that for this problem, we need to create a triangle to use Pythagorean theorem to be able to solve for this length. And we can do that by using the length of the cube and crossing this front face. So crossing from the bottom corner to the top corner, as so. So therefore we get a triangle, a right triangle like this. Let's label the side that we want to know as side C. Since we follow the length of the cube right here, or this length on the opposite side, we know that that side can be represented as A. So we'll call that A. And since we crossed the face, or if it'll be easier to be seen, we crossed it like this, we know that if we do Pythagorean theorem on that face, it's rad 2A. So now we can go ahead and plug in to Pythagorean theorem. So A squared plus rad 2A squared is equal to C squared. Working out the math, we get 3A squared is equal to C squared. Taking the square root on both sides, we get the length of our line for the direction 111 is rad 3 multiplied by A. Rad 3 multiplied by A. Now we're ready to plug in our value of A, which is the lattice constant of 0.405 nanometers. So let's go ahead and do that. So linear density is equal to 1 over rad 3 multiplied by 0.405 times 10 to the negative 9, which therefore gives us a value of 1.42 times 10 to the 9 atoms per meter. Now this isn't our final solution because we go back to the problem statement. The problem statement wants the linear atomic density in atoms per millimeter. So we do that by dividing our answer by 10 cubed, therefore giving our answer in atoms per millimeter, which is equal to 1.42 times 10 to the 6 atoms per millimeter. And that is the solution to problem 4C.